Hello, this is the luckiest maths teacher in the world. Today, talking to you about multiplying and dividing indices. So first, let's go ahead and look at what they actually are. So you've probably seen something like this before in your life. 4 with a little 5 to the top right of it. And we read that as 4 to the power of 5. So this number here is the power, but it's also called the exponent or the index. And indices is just the plural of index. So we're working with numbers that have been raised to a power. Now we call this number here the base number, and I'll be referring to that, I'll be using that terminology in this video. So, probably already know that 4 to the power of 5 is just a quicker way of writing 4 times itself 5 many times. So the base number is the number that you multiply, and then the index number is how many times you multiply that number by itself. So 4 to the power of 5 is 4 times 4 times 4 times 4 times 4. There are 5 4s there because the power was 5. So this form here where I write out all the 4s, this is called expanded form. And because the first one that I wrote had an index in it, it's called index form. So make sure you know that, because there will be times when you get questions that say, give your answer in index form. And that means you have to write it like this. Okay, so let's go ahead and look at 2 index laws, one involving multiplying and one involving dividing. So let's say I have something like 2 to the power of 4. So make sure you don't make the mistake of thinking that that equals 8. It's not 2 times 4, it's 2 times itself 4 times. Okay? Now what if I wanted to multiply that by another power of 2? Let's say I wanted to multiply 2 to the power of 4 by 2 to the power of 3. Well, I've already got 2 to the power of 4 here, so I'm just going to multiply by 2 to the power of 3. So this part here is 2 to the power of 3, and this part here is 2 to the power of 4. So what you notice, I hope, is that now there are 1, 2, 3, 4, 5, 6, 7 2s, because I had 4 originally, and then I added 3 more on. But if I multiply 2 by itself 7 times, that's 2 to the power of 7. So 2 to the power of 4 times 2 to the power of 3 equals 2 to the power of 7. And that gives us our first index law. So I'm going to go on to a new slide, so please pause the video and copy down if you need any of this. So I've written for you the index law that I just spoke of in a generic form. I've used A's and B's. You can substitute A, B, and C for any number. But basically, this says if you multiply the bases, you just add the indices. But this rule has sort of a caveat to it. It has a condition. It must be the same base. So you can only use this rule when you're using the same base. So notice I've got A and A. That's the base number. So what I'm saying is, I'll give you some examples. So let's say I have 3 to the power of 8 times 3 to the power of 9. In index form, that is 3 to the power of 8 plus 9, which is 17. So that is index form. If the question said simplify in index form, you give it as something to the power of something. If I have 2 to the power of 11 times 2 to the power of 20 equals, say, 2 to the power of 31, because I just add 11 and 20 together. If I have something like this, so let's say I have 4 to the power of 6 times 5 squared times 4 to the power of 8. This part of it, 4 to the power of 6 times 5 to the power of 2, doesn't equal 20 to the power of 8. Just like when we were learning about like terms, remember how we can't add terms unless they're like terms? When we're using indices, we can't multiply them unless they're the same base, at least not at the level at which you're doing this. So 4 to the power of 6 and 5 to the power of 2, they have different bases. The base of the first number is 4, and the base in the second one is 5. So what that means is I don't combine them. They don't touch each other. They're not friends. They won't have anything to do with each other. So similar to when I'm adding and subtracting like terms, I'm going to take the ones that you can multiply together and just operate on that. So 4 to the power of 6 times 4 to the power of 8 gives you 4 to the power of, now 6 plus 8 equals 14. And then I just leave the 5 and its power as it is. I don't touch it because it's a different base. All right, I'm going to go on to the next law, which involves division. So again, please copy this down and pause the video if you need it. Okay, so let's say we have something like this. We have 2 to the power of 6 and we want to divide it by 2 to the power of 4. Now, what I hope you remember is that when we're dividing something, we can write it as a fraction. Sometimes that's easier. For example, you can write 9 divided by 18 as 9 over 18. I'm going to do that trick here. So on the top of the fraction, I'm going to write 2 to the power of 6. I'm going to write it in expanded form. So there should be 6 2's. Okay, so that's 2 to the power of 6. This middle fraction line here means divide. So on the bottom, I put 2 to the power of 4. Again, I'm going to write it in expanded form. Okay. Now, hopefully you also remember that when you have a fraction, you can cancel common factors. You can cancel something that is a factor of the bottom and also a factor on the top. I can cancel some 2's because they appear on the top and the bottom. So I'm going to go ahead and cancel 4 2's on the top and on the bottom. I can do that as long as I do to the top of the fraction what I do to the bottom of the fraction, then it's fine. So I'm left with 2 times 2, or 2 squared. So what you can see here is that I've subtracted this number of 2's from this number of 2's. 6 minus 4 equals 2, and that's how I got the number there. So this would have worked, whatever number I chose, if I chose, 3 to the power of something or 5 to the power of something, as long as, again, the bases are the same. So that is our next index law. So again, I've written it generically using A's, B's and C's, but you can substitute A, B and C for any number. Well, in this case, we're just looking at positive integers. So A to the power of B divide A to the power of C equals A to the power of B minus C. So in layman's terms, what I'm saying is if you divide the bases, you subtract the indices. Now again, must be the same base. Only works for our purposes if you are dividing the same base. So let's do some examples. So let's say I have 11 to the power of 13 divide 11 to the power of 5. So in index form, that's the same as 11 to the power of, now 13 minus 5, that's pretty easy to do, that just equals 8. So 11 to the power of 13 divide 11 to the power of 5 is 11 to the power of 8. Notice I use the same bases. Let's say I had 8 to the power of 6 divided by 4 to the power of 3. Now, I actually can't do anything with that. I can't simplify that any further because I don't have the same base, okay? I will just digress to say there is actually a way to simplify it a little bit, but we're not looking at that this year. So for your purposes, if they are different bases, you can't simplify them. Just like if you have two unlike terms, you can't simplify them. If you had something like this, let's say 8 to the power of 9 times 5 squared divided by 5. Okay? So then I can write this as a fraction, but remember, I only worry about the bases that are the same. The 8 and the 5 are different bases, so they can't do anything. Now remember, if something doesn't have a power written, you assume it's 1, because 5 is the same as 5 to the power of 1. So what I do here is I leave the 8 to the power of 9 alone, and then I just focus on the 5's, because they are the same base. So 5 squared divided by 5 just equals 5. All right, fantastic. Hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.